Hello. So today we are going to be talking about Quartus IP Generator. So in this video, I'll be implementing soft IPs, especially the multipliers on DE1-SoC board using the Quartus IP Generator and Configurator. So in this experiment, using the IP Generator, I'll be implementing a 4x4 multiplier using different configurations of the generated IP. To generate the IP, we'll go to IP catalog, basic functions, arithmetic, and LPM mult. We'll just provide the module a name and proceed forward. Here it will prompt us a window to configure our multiplier. So for inputs, we'll be providing 4 and 4, and will automatically calculate that there'll be 8 bits required for the output. Here we are gonna set everything as default to see how the implementation is being done. We'll keep the multiplication as unsigned to keep it simple. And for pipelining, we are not providing any pipelining here. We'll just see how the default configuration of the module is being done. The same thing goes for the optimization. We'll select generate netlist. So this will create a Verilog module which consists of our multiplier module. So here you can see there are two inputs, data A, data B, and result, where data A and data B are 4-bit wide and result is 8-bit wide. And all this code is being auto-generated based on the module specification. Since we have kept it at default, the speed it will be 5. It is a unit ranging from 1 to 9, 1 being area optimization, 9 being speed optimization, and here since we have kept it at default, it has selected 5, which is in between speed and area. Rest everything is similar to our configuration. Unsigned input A is 4-bit wide, input B is 4-bit wide, and the output will be 8-bit wide. So based on that, it will call the LPM multiplication module by passing these values. And the configuration here will be used by the compiler to perform the compilation as per the design requirement. We are also providing the design constraints where we are providing the clock period of 20 nanoseconds to match the board's 50 megahertz onboard clock. I'm also providing a test bench with different configurations of A and data A and data B to see how the result is being generated. We'll go ahead and compile this Verilog module. So let me bring up the simulator, RTL simulation. In the simulation tool, first we'll go to compile and compile something called as 2020 model. So this will contain all the multiplication module that are required for the IP generated module. So we'll compile that, and then we'll compile our test bench. As you can see, once the 2020 model has been compiled, there are several modules that are imported. What we'll be using is the LPM mult. So once the simulation has been done, we can see different modules being brought in for the work library. So here we'll be selecting our test bench and simulate. We will load our signals to the waveform window so that we can see the waveform generated. We'll go ahead and simulate it. Simulation, run all. Here you can see the results. When data A and B are 0, result is 0. When data is 1, result is data B is 0, result will be 0. 1 1 is 1. 15 15 is 255. 10 10 is 100. 8 2 is 16. 12 15 is 180. 5 13 is 65. So this confirms that the simulation or the module is working as per the requirement. Same thing goes for the waveform. Here you can see at the time frame of 5. For 5 intervals, our input was changing, and result can be seen here. Here we are seeing the result in hexadecimal, and the output I was outputting it in decimal value. Now that the simulation has been completed, let's push the bitstream to the board to see the performance on the board. For that, we'll go to Assignments, Pin Planner, and here we'll be assigning the pins, the netlist to its respective pin location, which I've already filled the locations. The pin assignments have done in such a way that the first four switches are for the data A, and the last four switches are for data B, and LEDs, the last 8 LEDs I've assigned it for the result. Let's go ahead and program the device. We'll go ahead and click auto detect. Once that is done, we'll select our chip, edit, change file, and we'll select the SOF file and start. So this will push the bitstream file to the board. Once the bitstream has been pushed to the board, we can perform multiplication on the board. First we'll put input B as 1 and A as 1, and we can see the output is bit 1. It is 1 into 1. Let's put 2 and 1. A is 1 and B is 2. We are getting output as 2. I'm setting A as 2 and B as 2, and the output is 4. Let me set everything as both as 15, and the output is 225. And the same can be seen on the LED. And if B goes to 0, the output will be 0. So from this, we can conclude that 4-bit multiplier using the IP generated modules is working as expected on the DE1 SoC board.